Hello everyone, welcome to Physics Tutorials. My name is Ganga Bhavani. This is session 5 of Fundamentals of Physics. In this session, we are going to see what are vector quantities and what are scalar quantities. We all know that mathematics is the language of physics. It is much easier to describe, understand, and apply the physical principles if one has a good knowledge of mathematics. Let's see what is a vector. Certain physical quantities requires a numerical value as well as direction in space. Such quantities are called vectors. For example, velocity, force, electric field, magnetic field, and linear momentum. These are the examples for vectors in physics. The vectors are denoted by putting an arrow over the symbols, like we can represent them as V bar and F bar. So the front part of the arrow is called head, the rear part of the arrow called tail. Let me give an example. Let's say a particle is moving with a velocity 5 meter per second. Means the magnitude of velocity represented by a number such as 5 meter per second and tell us how fast the particle is moving. But the description of velocity becomes complete only when the direction of velocity is also specified. We can represent the velocity by drawing a line parallel to the velocity and putting an arrow showing the direction of velocity. So, we can represent the velocity of a particle which is moving at a velocity 5 meter per second like this. Let us see what are scalars. So there are certain physical quantities which are completely described by a numerical value alone and are added according to the ordinary rule of algebra. Such are called scalars. Let me give an example. Mass, time, distance, speed, like this. So many examples are there for scalars in physics. Let's say the mass of a system is described by saying that it is 5 kgs. Now I'm taking two bodies. One is having mass 5 kg and another one is having mass 2 kg. And I'm adding this two or making a composite system. The total mass is 5 kg and 2 kg. The resultant will get 7 kg. This is, I'm adding it as per regular algebra. So we can add scalar quantities by using regular algebra rules. And not only like this, we can also define vector quantities as scalar quantities by using triangle rule. Let's have a look what is triangle rule. Let's say if a particle is given two velocities simultaneously, its resultant velocity is different from two velocities and is obtained by triangle rule. Let's say the first velocity of particle is along AB bar and second velocity is along BC bar. So the resultant velocity is along AC bar. Means draw a line AB representing the first velocity with B as the head. Draw another line BC which is representing the second velocity with its tail B coinciding and with the head of the first line. The line AC with A as the head and C as the tail represents the resultant velocity. Here the resultant also called the sum of the two velocities we have added, that AB bar and BC bar, and obtained the sum AC bar. So if we add AB bar and BC bar, we can get the resultant velocity along the direction AC bar. Let me give an example. Let's say a small ball is moving inside the tube at a velocity 3 meter per second and tube itself is moving at a velocity 4 meter per second, which is moving perpendicular to its length. So in this diagram, we can clearly understand the particle, means the ball, which is moving inside the tube with a 3 meter per second and the tube itself is moving 4 meter per second. And here the positions of ball at t equals to 0 sec and t equals to 1 sec inside the tube. And the ball is moving in a direction in the direction theta equals to 53 degrees from the tube. So the resultant we can get 5 meter per second along the direction with an angle theta equals to 53 degrees. So by triangle rule of addition, we can define vectors, scalars as the physical quantities which have magnitude, direction, and which can be added according to the triangle rule are called vector quantities. There are some physical quantities which have magnitude and direction but does not add according to the triangle rule. Those are not called vectors. Let me give an example. Electric current. Electric current should be considered as a vector as it has both magnitude and direction. But in addition, electric current does not obey triangle rule of addition. For this reason, current is a scalar quantity and it is not a vector. Hope you all got the clarity about vectors and scalars and triangle rule. See you soon in the next session. Thank you.